Hello everyone! It has been like 3 years since I've tried this properly. I did try to do this particular thing a few weeks ago and it didn't go well because I'd managed to set a bunch of keyboard shortcuts like start and stop streaming was the same as build my software, which is a silly mistake to make. Here's hoping that if you are watching this live, you can hear me properly. I have a mic just off shot here. The next purchase I'm going to make is a mic boom arm because it's currently sat on the desk, the same desk that the keyboard is. So you may hear some clacking, and if you do, then I'm sorry in advance. But here's what we're going to do. I'm just going to take a sip of this water. Hide in the label there because I want to. But here's what we're going to do. Right, we're going to build, or at least I'm going to try and build, a Roman numeral parser from the ground up. Now, for those of you who don't know Roman numerals, let's go and check this out. Right, so let's just do this. And we're going to go Roman numerals. Really should have loaded this up well in advance. Okay. Roman numerals. Okay, so Roman numerals have a very restricted character set. I, V, X, L, C, D, and M. Just zoom that in a little bit for you. And what we're going to do is we're going to write a parser that takes in a string of Roman numerals and gives us the number output. Great thing about Roman numerals is A, there's no such thing as a negative number. I mean, there kind of is, but that's a really complex setup. There's no such thing as 0, and there are no decimals. There kind of are, but that's a complicated setup. We're going to go with the basic setup here. These are the rules here. I is 1, V is 5, X is 10, L is 50, C is 100, D is 500, and M is 1000. I'm going to keep this window open as we work our way through this whole thing. You'll notice there isn't any flashiness with this stream. It is quite literally me sitting in my office, working on the machine that I use to do my normal everyday work. And I got some posters in the background and some books that I'm reading. But anyway, let's get started, right? Because there ain't no time like the present. So what I've got here is I've got Rider open, and it has nothing in it. We've only got a solution, right? So if I go to, can you see this? Hopefully you can. Let's go show in files. You can see that I just have a path. Unfortunately, we've got Roman numeral parser, which is a shame, but we'll have to deal with it for now. Okay. So first thing we need to do is we need to add some folders, right? So let's go add a new solution folder, and I'm going to call it source. Actually, I should call that src. Let's rename this. Edit, rename control R. Huh. Oh well, it's not showing me the rename control, but that doesn't matter. So we'll do. We'll delete it and recreate it. Delete that. Yes. I'm going to call it src. Whoops. Add new solution folder. src. Right, and then we're going to add a new one called test as well. Add a new solution folder, tests, because we're going to do this test-driven development, right? So inside the tests, we need to start writing our tests, right? So let's add a new project. Huh, interesting. Oh well, tell you what we'll do. We will go, I don't know why this has happened, but it just has. So let's see. Oh, interesting. Get rid of these then. Start again. This is a bit annoying. src. And we'll go tests. You can't even see that because it's not even in the right place. There we go. So then I'm going to go into tests. I'm going to go open a new terminal. I'm going to go .NET new xunit. Yeah. Okay, excellent. Let's give this a second. Excellent. So that's that added. I've had to do it the long way, and I don't know why. Add an existing folder source. Nope, that's not right. Oh well. Yes, delete the thing. Fair enough. That's being weird. Add an existing solution. I'm not very good at this today, but there you go. We're going to go like this. Ha! Is it doing its thing? There we go. Oops. Okay, so now we have, hopefully you can see, a file called unit tests 1. I'm going to increase the font a little bit. 1, 2 clicks, 3 clicks, that'll do. Okay, we've also got some empty using statements, but that's fine. What we'll also do, I haven't got that, so we'll go showing files. For some reason, the version of .NET that I'm using, I deleted the folder. Okay, the version of .NET that I'm using isn't showing up properly, but that doesn't matter. .NET new console. I'll just do that there. So what I'm doing here is I'm doing some interesting. There's no one in the. Oh well, that's fine. What I'm doing here is I'm doing some scaffolding using the terminal, right? But that's not a problem. Just going to do this. Just bear with me a second. I just need to check something. We are indeed live. Okay, fair enough. Just checking that we're live, folks. Okay, so and then we're going to go add existing project. I don't know. You shouldn't have to do this, but I'm doing this because my setup is maybe a bit weird. I don't know. Okay, so we now have a program.cs and we have a unit tests. What I'm going to do is I'm going to 1, 2, 3, make that a little bit bigger. We don't want to do what we want to do. We want to build this as tests first, right? So the first thing we need to do is we need to agree how we're going to do this. So I'm going to create a Parser class, and the Parser class is going to be given a string, okay? And we're going to build that up as that's the one. So we are going to build this up as a class that takes in a string. Whoops, sorry. It takes in a string and gives us back a number. So first thing we need to do is go back here. We're going to go public class parser. Whoops, parser. There we go. Excellent. We now have a class. First thing we need to do though is check that that exists. We have to do what I think is the world's stupidest tests, right? These are going to be the parser tests. So let's rename this. So this is parser tests. I like to do this. Parser tests. There we go. And then we need to rename that parser tests. Okay. So I like to do parser tests should exist. Now this is something that I picked up from someone when I was learning TDD, and you start with just enough code to make it compile. Silliest test first. You test to make sure that the thing exists. Oh, awesome. Excellent. So up there in the chat, fella, your chat settings are still set to waffling tailors. Whoops. Okay, fair enough. Sorry about that, everyone. Let's see if we can fix that live. Whoops. Let's fix that live. Let's do. Okay, so that should have fixed now. Haha! There he is. It's the cynical developer is in the chat. Haha! There he is. Hopefully that's affected everything everywhere, but we'll find out. So we're going to do the stupidest test first. Thank you very much, Squidge. That was Squidge, my brother Mark, for letting me know about that. So the first thing we need to do is make sure that it exists. So we're going to do the arrange, assert, whoops, arrange, act, assert loop. This is, like I said, the silliest example. Var parser equals new. What did we call it? Parser. Parser. Right? Whoops. Nope, that's not what we wrote. Parser. That's right. I try to be helpful. Now this is going to fail, right? Because it doesn't know about parser. So we're going to say reference the source to parser. Excellent. All we need to do, right, is assert that parser is not full. Is not assert dot not null parser. The silliest test ever. I did try to tell you stuff before, but it wasn't showing up. By the time, by the way, sounds okay. I could do with a little bit louder. A little bit louder. All right, let's turn this up. How's that? All right, let's try that. Okay, stupidest test ever, right? Because what we're going to do is we're going to create a new thing and make sure that that thing is created. We're going to run the tests. So for those of you who didn't see that, I did Control U, Control K, which is the shortcut I have on this machine for run all the tests. Hooray! We have a passing test. Test-driven development, part 1 done. So first thing I want to do is I want to move this out to a separate file because it's easier to deal with. Okay. 1, 2, 3. Right. So the parser needs to be able to, well, parse stuff, right? So it needs to have a method that takes a string and gives back an int. So, fact public void should have parse should take string, return int. This isn't to everyone's tastes, the way that I'm naming these, but I'll go back and clean these up. So we'll go arrange, act, assert. First thing we want to do is we want to create a new instance of the parser. We'll tidy this up in a minute. The whole idea of this is I'm doing red-green refactor. We write a test and it fails, that's the red. Then we write the code to make it pass, which is the green, and then we refactor it to make it better, right? Because that's what refactoring is. Okay, so the first thing we want to do, we've got a new instance of parser, so we go for response equals parser, whoops, I can't type on this, oh dear. That all went a bit haywire, didn't it? Right, there's a parser dot. Now this is going to fail, look, because there's only 4 things that the rider version of IntelliSense can pick up. So we're going to go parse, right, excellent, for input equals, let's say 3 in Roman numerals, right? 3 in Roman numerals. Okay, we type in input. All of this is going to fail, so we need to assert not null response. It's going to be an int, but we're going to get some pop-ups. Is assignable, is type int response. All of these are going to fail. It's actually going to fail to build the tests, but that's fine. That's what we want. We want it to red-green refactor. That way, the theory behind red-green refactor is you only write enough code to pass the test, and that all the code that you write passes all of those tests. And so that's what we're going to do. Okay, so this is going to fail, so I'm going to do build. That's Control-Shift-B. And look, parser does not contain a definition of for parse. So first thing I would say is always read the error messages. Right? Sometimes they can be really obtuse, but most of the time it will tell you exactly what's going on. That's the first thing I always say to junior developers is what does, let me just move this on here, what does the error message say? And in this case, it's saying the parser class does not have a method called parse. And so let's ignore this, right? So this is like if there was an extension method called parse, but we don't need to know that. We know that there is not a method called parse. If I double click this, it'll take me to the line where it's fallen over, which is here. It says I don't know what parse is, right? So what we need to do, we need to go public. Remember, we need to return an int. Let's call it parse, and we need to take in a string input. Right? Now this is going to complain at me because it's missing a return statement. Right? We've satisfied the fact that that exists. Hurrah! Build again. We'll get a response from here. Not all code paths return a value. That means we're not returning anything at all. Okay, let's return something. Really doesn't matter. Red, green, refactor. Return 0. Excellent. That's returning an int. Everything lights up. Let's go. All we're testing is that we can give it a string and that it can return an int. That's all we're testing. Because that's what we build up slowly, right? Look at this. It works. Right. So, next test we want to do is that it actually returns the correct int. So let's take this test. I'm going to copy paste it because I'm lazy. It should return correct int value. Whoops. Okay, so we're passing in 3 and we want to get, so I'm going to go var target response equals 3. This is quite useful because I can then go check that it's an int, assert equal response target response. Excellent. Then I am hard coding stuff, but I'm not hard coding it multiple places. This test is about to fail because if you remember, this is returning 0. Okay, so we'll run it. I shouldn't really use that keyboard shortcut. I should just click down here. You can set these up actually in Rider. It's really cool. You can set these up to automatically run the tests every time you change something. So why did this fail? So it failed because the expected result was 0 and the actual result is 3, right? So let's go fix that. And we know that it's returning 0 instead of 3 because it does that. Okay, so let's do this a really cheap and easy way. Let's do hard code it to return 3. And we'll see that it passes. Excellent. Except that only passes in this case. We could copy paste this test and run it a whole bunch of times, right? But I'm using XUnit, and XUnit is great for this because you can go theory, and I could say inline data, and I could say, oh, bother, 3. So this means, so this is a string input, whoops, input, int target output, like that. Get rid of those two. Oh, should be target output. Okay, so now when I run it, it is exactly the same as before, but what happens is every time that I run all the tests, it runs this block for every single inline data I supply. Great, right? So let's do another one. Inline data, just to show you what this does. So we're going to say 1, and we want to return 1. Because if we go back to, where are we? Yeah, if we go back to here, we can see that, oh, my mouse pointer is way off. Oh well, I don't know why that is. But we can see that when we give it the symbol I, it has a value of 1, right? And if we look here, 1, 2, 3, 4, 5. We'll discuss these rules in a bit, but you can see here, look, the notations IV and IX can be read as 1 less than 5, which gives us 4, and 1 less than 9, 1 less than 10, which gives us 9. Your equal params are the wrong way around. They are indeed the wrong way around. Thank you, Cynical Developer. I'll go and switch those in a moment. So if we pass in I, we should get 1. If we pass in 3 I's, we should get 3. We'll make that a little bit more. There we go. Okay, so we expect to get the target output, but our actual response is that. So let's run these tests. Thank you very much, Cynical Developer, for pointing that out. It's an easy mistake to make. And what I really like about Rider is it shows you these things. Now, this has failed, right? Because it lists it lists each of these tests, but it now lists this one with 2 sets of input data. This is saying we expected, let me see if I can zoom that in. We expected to get 1, but we got 3. And that is because, regardless of the input, we're returning 3, right? So, again, the smallest amount of code possible, right? Input, switch on the input, case, I, return 1, default, no, that's decimal, default, return 3. So I'll explain this in a moment for people who don't know what a switch is, because some people don't. Is that my coding hat? Says Scridge. Maybe it's just the hat that I want to wear today. For those who don't know, it is a Coding Blocks hat. Cue the Cynical Developer complaining at me about not receiving his yet. Coding Blocks is an amazing podcast if you are into development. I don't make it, but my good friends Jay-Z, not the real rapper Jay-Z, Alan and Michael make it, and it is really good. If you're into development and you want to take your stuff to the next level, definitely check it out. Okay, so what we're doing here is we've created a switch. This says for each of these cases, do something different. So when I pass in a capital I, return 1. If I don't give, if I don't tell you any other cases, then return 3. Right? I could say case Jeff, return 100, which is a nonsense case. But if I pass in the capital I, I'll get one out. If I pass in the word Jeff, I'll get 100 out. And if I don't tell you, if it doesn't fit either of those two, return 3. I'm going to delete that Jeff one because that's a bit silly. So now if we run these tests, it's Cheeky Labs afternoon. Hello, Cheeky Labs. Thanks for stopping by. Yes, so we're doing TDD. I've chosen Roman Numeral Parser because it's relatively easy. I may not get all the way through it. Mostly this is a test to see whether my whole setup actually works. It's not as flashy as some of the other streamers where they have like green screens and they have like balloons coming up and CG stuff. This is sort of back to basics. So we're doing red, green, refactor, right? So we've now got red and green. We've got to the green. We've refactored to get it green again. Then we need to refactor again because this is kind of nonsense, right? Because if I do this, and if I say I want IV, which we've seen in here, where are we? I think my mouse button is showing up twice, but there you go. IV is the same as 1 less than 5, which is 4, right? So if we go back here, stream quality is absolutely fine. Thank you ever so much, Cheeky Labs. Right, so we're saying when we pass in IV, we want to get 4 out. This is going to fail again because remember the code doesn't actually parse anything, right? This one's going to fail. Look, you ready? Oh, right. I've told it to run one test, not all of them. That's the problem with just clicking that button and fail. So it expects it to get 4, but it actually got 3. And the reason for that is because I said here, when I pass you I, give me 1. Otherwise, in all other instances, return 3. Now I could continue to write this. I could say case I, sorry, not I, IV, return 4. But then it gets a bit daft because then I have to like manually write all of this code. We don't want that. What I'm going to do is I am going to go over here. We don't want that. What we actually want to do. You've always wondered what Gaprogman came for. Care to tell us the story? Okay, I will. So take a little bit of a break before we carry on. Let's go to the Talky Talk window. Haha! So, the background here, by the way, over there, yeah, is the output of an app that I use, that I've written myself. It's a .NET global app that I use when I create the show notes for each episode. I really should shift that text across, but it's burnt into, oh, it's not burnt into the image. Let me see. Excellent. Okay, so let me move this across. Haha! I'm doing this live. There we go. Excellent. So that's the output. You can't really see it because of the whiteness of the eyes. Oh, also, Cynical Developer in the chat is the person who created that logo for me. So if you want a logo creating, I'm sure you can go and have a chat with him. Maybe he'll be able to do it. I don't know his work schedule. But anyway, right, okay. The genesis of the name Gaprogman, which I've heard pronounced as GA Progman, Go Progman, Goo Progman, is the genesis of it is a friend of mine, dear friend of mine, Lee, unfortunately has passed away. We were sitting around one day at uni and he said to me, we were talking about superheroes, right? This was like 2003, 2004. Yeah, 2003, 2004. And we were talking about what our superhero names would be, what our superpowers would be, would we, if we were superheroes. And I said, hey, I'm studying games programming because I did a computer science games dev degree. And so I said, well, my name would be Gaprogman. I'd have the power of programming games. And I would stand around in a crowd, hands on the hips and go, Gaprogman away! And then everyone would look up there and I would sort of duck and crawl under everyone's legs to run away. And that's where it's come from. He said, yeah, Gaprogman, that is a name for you. So that's where it kind of came from. Hopefully that answers the question. It's a bit silly, but there you go. Okay, so where were we? Ah, yes, right. So we were talking about how we were going to do this. Oops, I've lost my windows. Okay, so first thing we want to do, actually, let's take a step back. Before we start parsing, where's all my windows? There we are. Before we start parsing this correctly, what we actually want to do is make sure that we're passing in a valid string. And so what I'm going to do is I'm going to create a, oh yeah, we also, yeah, so if I run this test again, so I've created that case, it's now going to pass. But what we need to do is we need to protect against that string being a bad value, right? Because what happens if I pass in, what should it be if I pass in Jeff, right? Or if I pass in an empty string or a string with a bunch of spaces. Should it be 0? Should it not, right? So first thing we need to do is we need to protect that. Now we could just go if in string dot is null or white space input, then handle that, right? Great. So for Squidge's benefit, he's in the chat. This basically says take this and check whether it is not equal to anything or if it's just a bunch of empty characters, right? So if input equals, right, if I did that, then we would end up in here. Whereas if I did that, we would end up here, right? But we also want to protect against stupid input, right? So the first thing we need to do to be able to do, because I mean we could, let me just undo that, right? We could totally have that and then do if and some kind of regex match to make sure it fits. But what I like to do is I like to create what I call what is called a guard clause, right? And that's usually created as an extension of the string class. Let me just do this. Okay, so what I want to do is I'm going to step away from the parser because I'm going to add something to it. But before I add something to it, I need to test that, right? So I'm going to create a public static class, whoops, calls apparently, class called Roman Numeral God. Yeah, Roman Numeral God. Whoops. And in here, what we want to do is, numera God. We'll need to write some tests for this as well. But this is going to take a string and it is going to use that to actually guard against something not being null, not being empty, not being equal to the set of characters in a Roman numeral. And the way we're going to do that is we're actually going to say public static, we want a void. Yeah, we want it void. We don't want it to return anything. And we are going to give it a list. No, we're not going to give it a list. We're going to go non-Roman numeral string. And we're going to say this, no, not string, this string input. Okay. Oops. Okay. So for those who haven't worked in C#, this is what's called an extension method. This means that I can now go input dot non-Roman numeral string, which is not a method that exists normally. I've just created it, right? I can just literally call it like that. What happens is at build time, this parameter, like, because we have to usually pass things into methods, right? You saw this earlier on. When we call parse, we have to give it a string, right? So this says take this and actually operate on it, which is what the this here means, which is really useful, but it needs to be static in order to do that. There's all sorts of stuff involved in that, right? But let's get rid of this, right? Okay. Non-numeral. So what we want to do is okay. Must. Right, what we'll do, what I'm doing here, let's cancel out of that, right? What I want is, I don't want it to be called non-numeral, so it must be Roman numeral, right? So the must be Roman numeral is gonna make sure. So if I go input, whoops, input dot must. Ooh, I can't type, honest. Okay, so I could just literally call that. It will jump into here, and here is where I'll do my check. So not wanting to break your flow, but I used to watch a program do this when I used to walk home on a Saturday from my old job. I honestly didn't know that. I'm going to say Squidge, but he's in the chat as Waffly Taylors. I honestly didn't know that, Squidge. That's interesting, but there you go. So I'm going to call this here, and I do the check there. So the reason for this is so that I don't have to copy that check elsewhere. So what I want to do is I want to check if string dot is null or white space input. So for those who don't know, is null or white space is a wrapper around is null or empty, and then checks for like white space characters. It does a whole bunch of stuff. I've just gone to source there, but you don't really need to see that. So this means if we pass in an empty string, remember if I said input equals that, or if I said equals that, which is a cool sort of static entry that's not a compile time entry, but it's quite useful. If we pass in an empty string or a string that's just an empty like spaces, then we'll get into this loop. What I like to do at this point is I like to throw, actually, what we'll do, I won't do it, right? Because what we need to do is we need to test that. So let's create a new test class. Let's create more tests, public class, Roman numeral God tests, right? Because otherwise, you saw it just then. I started to write code. This is not what we want. I'm going to take that out. Comment that out. So again, for Squidge's benefit, or any junior devs, or any people who are looking into dev who don't know what it is, that means ignore this line. Totally easy, right? Okay, so what we want to do is when we go public, void should exist. That one's not going to work because it's a static class, right? Can't really check that it exists. So we're going to do public. We're going to go public. We're going to go void. All the tests, indeed, Squidge. You'll learn if you're interested in this that it's good to have these tests, because then if I go back into here and change how this works, I can rerun all the tests, and then I will know that it works. Right? I know that the changes that I made didn't break anything. That's my personal opinion on unit tests. Some people like them, some people don't. Okay, so what we're going to do is we're going to go public void, and we want to do should raise. We're going to throw an exception. We're going to throw argument exception when input empty. Yeah. Or oh dear. Oh no. Dear. There we go. Okay. So we're not calling this yet, so it's going to be grey, and then I'm going to go fact. Okay, so here's the great thing about unit tests is you could totally write empty unit tests. This test will pass. Great success. So the reason that test passes, how do you know your tests are right though? Should you test your tests? That's the difficult thing, right? You end up going down this rabbit hole of testing your tests. It is a very important philosophical question, and the idea is that the tests represent how you have built the software, right? And that way you can show the tests to someone else and say, this is my understanding of the problem that I'm trying to solve. And they can read through the tests and go, ah, I see what you did there. You got this thing confused, or this thing is not quite integrated the way that it should be. So yeah, you should really test the tests, but this is like automated testing. You should test the tests by reading through them and making sure that they do what you think the code should do, because this is a great way of showing someone, hey, I can run these tests and the code is doing what I'm telling it to do. So the reason this test passes is because we're not doing, you see what we did here? We did assert, right? This means check that this is not null. Check that this is equal to something, right? Because we're not asserting anything. We could go assert equals true, false, false, apparently. There we go. Right? Now the test will fail because true can never equal false. Ready? This is another common trap that people fall into when they're doing test-driven development, is that they assert things that will always be correct, right? You can do assert true, true. You can throw this into so this says, make sure that whatever I put in here is equal to true, and because true is true, this will always pass, right? There's a common sort of joke that gets thrown around. I've written loads of tests and all I do is assert true, so I've got loads of tests, which is ridiculous. But let's move away from that. So what we're going to do is we're going to do arrange, act, assert. This is great. This is the great way of, I think this is a great way of writing tests, because you separate all of the code that does things, the 3 steps of your tests. You want to arrange everything so that it's ready to run. You then run some code, and then you check the responses of that code. Great, right? So we're going to go var input equals an empty string, right? We're going to go var response equals, oh, we need a parser as well. We will tidy this up later. We're going to parser. There we go. Then we go parser dot parse input. Whoops, input, like that. So this says create me something to actually convert my string into a number. Create me something which stores an empty string, and then go and actually put that thing into here and see what happens. Right. What we want is we want this to do something. We want it to raise an exception, right? So there's 2 ways around this. We can either call the code, capture the exception, and then check things about it as we go, or we could just catch the exception. So there's 2 ways to do this. We could go try, excuse me, var response equals parser.parse input. So this try catch is pretty cool. Again, for non-developers and junior developers, this means go and try this, and if anything happens, I want you to catch an exception. So an exception is something that is raised by the software that says, this is exceptional, this shouldn't have happened. Right? Would there ever be a point where you would create a test to see if something will fail in a specific way? Like if you think it's going to break and do the wrong thing, could you test to see if the wrong thing shows up and report it as a success? Or we're doing this only confuse things. You've actually asked a really important question there, Squish. There's two ways to deal with that. One is I'm actually doing a test here for if I give it some bad data, I want it to protect against that. And that's what we're doing. But the other way is if you have tests like this and you know there is a bug in the system, you can write a test which recreates those steps, right? And then you have something that you can then run hundreds of times and see when the test happens. So let's say you have, let's say this parser that I'm writing fails when you give it just the letter I, an uppercase letter I, right? And it fails every single time. You can write a test that recreates that, then you go and fix it, and then when you come back and run the test, it will then fail because you've fixed it, if that makes sense. So you're testing for that negative condition, that wrong condition, and you run that test against the code, and the negative condition will pass because the negative condition happens, right? You still get that problem shows up. You then go and fix the code, run all of the tests again, and the only one that should fail is the test that recreates that bug. Does that make sense? I hope it does. Hope that makes sense. Negative tests are a good thing. Indeed they are, cynical developer. They are indeed a good thing. So what we can do here is we could go assert. I'm not saying that this is the way that you should do it. Exception E and assert not null E. That's one way to do it, where you say go do the thing, and if it raises an exception, assert. That's not the way I like to do it, so I'm going to do it a slightly different way, right? What we're actually going to do is let's comment that out. What we're going to do is we're going to go var exception response equals, and this is something that let's have a look. Can't you just use assert dot throw? You can. That's another way of doing it. Assert dot throws, absolutely, and then you go argument exception, and then you would say parser dot parse, I think, input. You could totally do that. Whoops. You absolutely could do that. This is and yes, you're absolutely right there, cynical developer. There is never a daft question. If you're talking about development work, it is never a daft question. So yeah, it's not a daft question. And you're absolutely right, W Gaffer. I hope I'm pronouncing that right. Thanks for stopping by. You can do assert throws, which is brilliant. Problem is with that one, if I want to check something in the exception, so I'm about to, when I add this guard method, I'm going to add a reason why the exception was raised. Now, if I write that, I can't actually check what the message was, because I'm gonna do some message stuff in the exception. So for Squidge's benefit, when an exception happens, you get a message that says, "Hey, this is why it broke, and this is where it broke." Right? So with this one, I'm gonna write this so that when you pass in an invalid value, it's going to say, hey, your value is invalid and it needs to match this sort of setup, right? Because otherwise, as a developer, I don't know why it broke. So I could do that, and you've made an absolutely fantastic remark there, W Gaffer, but that's not the way that I prefer to do it. The way that I prefer to do it, let's just check here, I see what you're doing, go through the different things, I get what you're doing on the channel. Okay, fair enough. Thank you very much, W Gaffer. Hopefully I'm being quite clear. I realise I'm going through this really quickly. But what I want to do is I want to response exception equals, right? I want to say record exception. So this means go do a thing, and when the exception is raised, record it and store it here, which can be really useful. So I'm going to say parser.parse input, input. So this thing here, these brackets and this equals an arrow, means this brackets is like create a temporary thing, and it means go and do this. This equals and then the arrow symbol. Gotta go do that parent thing and water and feed the future developers. Thanks, cynical developer. Just one thing to point out. I'm just going to go back here and just say for the people who turned up late, the logo in the background here is indeed based on the official .NET logo. I'm not a Microsoft employee. It's based on it, but it's actually created by the Cynical developer in the chat. So I want to thank him for that. But there you go. Have a good afternoon, Cynical developer. Okay, so this character here, the equals and the arrow, can be read, can be pronounced out as goes to or does this, right? It's always important to keep hydrated. So we're going to say go to this and then take if there should be an exception and store that here, right? And the reason I do that is because I can go assert dot not null response exception. I can also do assert is assignable from argument exception whoops, response exception, and I can go assert not null response exception dot message not null. Yeah, let's do not null. It shouldn't be null anyway, but not empty response exception message. Let's get rid of that test because that test is silly. It's never going to be null. Okay, and then we can go assert contains let's say the word input, right? Response exception dot message. So did it the wrong way around. Expected, actual, yeah, okay. So this now, I don't have to call this thing multiple times to check the different properties of the exception. That is an awesome logo. Thanks, Rich. And no worries for logo. Catch you later, dude. See you later, Cynical developer. What I'm doing here is I'm capturing that exception, and I can check multiple things about it. I can check, did I actually get an exception? And if I did, is it one of these types of exceptions? And if I did, make sure that the message is not empty, and if it is not empty, check that the message contains the word input. What was it you did, Cynical developer? Didn't have video. Oh, right, okay. So, didn't have a video saved on Twitch. So, for WGAFFA's benefit, this logo here, over in that top right hand, kind of like over there, I guess. I'm really bad at orientation, but somewhere over there. That purple .NET logo is something that Cynical developer created for me. And it's also the logo, let me just go back to show and tell, which is my other window. Where is my, there we are. He also created, it's the same logo that's used here for the .NET Core podcast, which is a podcast that I host. So if we go back here, I'm just going to go back to the IDE. Okay, hopefully you saw that. But what's great about this is I can then, this test is going to fail, right? But is empty or null. Okay, so, excuse me. We now know that all of these things, I can test against all of these things. And I'll rerun this, it's going to fail, right? And we'll see why in a minute. Let's see. Okay, so it's failed, right? It's a not null failure. This one here, right? Because an exception wasn't raised. So if we go back to this Roman numeral, first thing we want to do, oops, yeah, is we want to check if it's empty or white space. Remember, this checks for if the string looks like that, or if it looks like that, or that, or that, right? Any of those things, right? So if it is null or white space, we want to throw a new argument exception. Excellent. So what's this? Right, remember that somewhat. The logo was familiar. Indeed. Yeah, that I'm glad that the logo was familiar. So this, again, red-green refactor. We've broken the test. We've fixed it somewhat. We're going to run it again. We're going to run this test again. I don't know if it's debug, but it doesn't matter. Where are we? Oh, it's inconclusive. Let's run it again. This happens sometimes with Rider, and I don't know why. There we go. So, not found input in value. Value does not fall. Okay, so what it's expecting is here, right? It's that assert contains. If we look at the line here, line 24, click, it's this line here. It's saying that message does not contain the word input. Okay, so what we can do here is we can go, we know, or at least I know, if you look at the argument exception source code, you could, 1, 2, 3, you could pass it a message. So why don't we do that? 1, 2, 3, let's bring that back down. So why don't we say the message we're going to send is, now I'm going to do some advanced C# here by putting that $sign, but I'll explain that in a minute. Name of input is empty. Let's put it here. Is empty is null or empty. So this is really complex, this bit here, right? For those who don't know C#. What this does is everything between, okay Squidge, go enjoy having a cuppa. Everything between these two quotation marks is a string, right? The $sign at the beginning says at some point in this string I'm going to use squiggly brackets, which is my name for this character and this character, and when you see the squiggly brackets, this is going to be some C# code. Go run that C# code, then come back and put it where you see the squiggly brackets, right? So these squiggly brackets here, all of this is actual C# code. I could actually go, I could say 3 plus 2 and it would put 5 there, right? But what we're doing is we're calling this method called nameOf, which we pass a variable into, and it returns the name of that variable. So instead of going, I could say input is null or empty, but then if I change that to some var, then input will stay the same, right? Whereas if I do $wrap that in squigglies, name of some var, that will now be some var, and when I change that back to input, that will change back to input, right? So excellent. So what we'll do is we'll rerun this test. In fact, let's rerun them all. They should all now pass now. Good idea, Squidge. I'm going to have a cuppa too. Let me just turn this around. It's my .NET Rocks mug, which again is another amazing podcast if you're into development. Ooh. In the 5 milliseconds it took to run all of the tests, this one passed, because we now have an input is null or empty, right? So it should contain input and assert.contains null or empty response.message. That's another test that we can do, so that then when we change, if we change the exception handling stuff, we can then do all sorts of stuff. We can check this will fail in a moment, but we don't have to worry about that. Right, well let's again, this is like we're doing empty or null, right? If I wanted to, I'd have to change this to null and you rerun it and it doesn't like that. So why don't we go turn this into another theory, we go inline data, and we will say string input, whoops, input, and get rid of that. Then we'll go, first thing, we'll go null, then we'll go inline data, and we'll go empty string, inline data, and we'll go like that. And then one last one, inline data, we'll go like that, right? So when we actually run this test, it's going to run it 4 times. It's going to pass in null, it's then going to pass in an empty string, it's then going to be passing a single space, it's then going to pass in loads of spaces. Now, we could, I wish that we could go string.empty, but that's not a compile time constant, which is a really complex way of saying that doesn't actually exist until you're running the code. So we can't do that. It has to be a constant expression or a type of. So let's actually just go like this. Actually, what we can do is, okay, that's another test we can run, and I will run that in a moment. So we will do that. We'll do an empty string. So this one is the same as running this one, I believe. What default string does is it says, go get me the default value of this type and put it in there. So let's rerun this test. Let's rerun them all, right? Why not run it against tabs and yield? Absolutely. We absolutely could. We absolutely could, W Gaffer. I hope I'm pronouncing that right, hopefully. But like I said, this test is just for empty and null. We can do that in a moment if we want. In fact, we will do that without actually wanting to do that. So all of these passed. We can see it took 6 milliseconds to run all of these tests. This is what I love about unit tests. You can run them and rerun them and rerun them, and it takes almost no time, right? And you compare that with the amount of time it would take for you to manually test this code. 6 milliseconds is almost nothing, versus let's say it took you 5 minutes to run these tests. That's 5 minutes to run the test, but then maybe another 10 to 15 minutes for you to maybe write up a report, and then another 10 to 15 minutes for you to start being productive as a developer. That 5-minute test has just taken you 5 plus 10 to 15 minutes to write the report, then 10 to 15 minutes to get being back to productive. That's half an hour. That's 1/16 of your working day, right? Now, you could do your own magic calculation if you want as to how much that actually costs the company that you work for versus 6 milliseconds, which costs nothing. In fact, it's almost negative, right? But there you go. You've got a tea and a biscuit. Good on you, Squidge. I was just saying I'm drinking loads of water in my Donna Rocks mug. Ooh, there we go. Ooh. So the next thing we want to do is in here, we want to protect against it not being a Roman numeral character, right? So we've said that Roman numerals are, I, B, did we say X, C, D, M, and L, right? Let's just double check that, right? If we go back to this view over here, we've said I, V, X, L, D, C, and M. C, D, and M. Oh, excellent. I've added them, but not in the correct order. So let's go back here. I just want to move this one up. Just because I'm weird like this, it has to be in the right order. So those are the acceptable Roman numerals. If we pass in anything else, we want it to raise an exception, right? So what we're going to do is we're going to write some slightly complex code, but I will talk you through it as I'm doing it, right? First of all, we're not going to write any code. We're going to say should throw exception when, so what we're going to do is public void should, should. So the reason I'm doing this with should underscore, right, is because parse should take string, return correct int value. It's almost a sentence, right? So if we go back, should throw argument exception when input empty or null. It's almost a sentence, which means that when it fails, like when the test fails, and I do, I just copy this one and go Jeff, right? And I rerun this test. It'll tell me the reason I name them like this when it catches up. Where are we? Should throw argument exception when empty or null, input Jeff. It's told me almost in a sentence what it should have done and why it didn't do it. Great, right? Right, should throw underscore argument exception. Hopefully the keyboard clacking isn't too loud because it's right next to the microphone, but I can move it if in fact, let's do it. When input not Roman numeral, right? So again, this almost makes a sentence. Should throw argument exception when input not Roman numeral. That's pretty cool, right? What kind of biscuit have you got, Squidge? I'm interested to find out. So we do our arrange act assert loop. Why didn't this code work? Looking at you, Jeff. But Jeff is one of my placeholder names. Apologies to everyone who's called Jeff. It's one of the things that I picked up from Eddie Izzard. I'm a big Eddie Izzard fan, and one of his throwaway names is Jeff, and I've just always said it since then. You got chocolate hobnobs. Awesome, Squidge. Awesome. Right, arrange. We need a new parser, so let's just copy that. Arrange. We're going to act. Remember, we're going to record this exception, right? Let's just do this. It's going to say, hey, you haven't. So this is going to complain. Input is red because it says cannot resolve symbol. That means, hey, idiot, you've told me to pass input in here, but I don't know what input is. The way to fix that is to go var input equals, there we go. Now it's happy, right? So we're going to pass in a not Roman numeral. So I'm going to say Jeff, because Jeff isn't a Roman numeral, right? Sorry, Jeff, but that's just the way it works. You are not a Roman numeral. I'm sorry. In this instance, you are not a Roman numeral. what I'm going to do is I'm going to copy that assert list. For anyone interested, these headphones are actually, they're not playing the sound from here or anything like that. I'm listening to a whole bunch of different music, and I can share a playlist later if you want. Now, remember, this is where we are. Oh yeah, I need to put fact here to make it into a test. So, got to the end of my playlist. Interesting. How long will we be going for? 55 minutes. Is it the end of my playlist? No, it's not. Okay, so this is going to fail now because it's not going to fall over because, well, none of this is going to fall over because all we're doing is testing if it's not null. Right? So let's run. Scrooge there with his emoji usage. I love it. Damn you, Jeff. Well, it's not Jeff's fault. Oh, excellent. Yeah, just rerun that one. Let's rerun all the tests. So for anyone who's interested, what's actually playing in the headphones right now? Failed unit test is, let's come back to that in a moment. Right, what's actually playing is, where are we? I'll just show you now. What's actually playing is this album. I'm a big video game fan. I'm a bit of a vaporwave and synthwave fan, and Remix the Save Rooms is it is a set of synthwave remixes of Resident Evil music. Would totally recommend. I'm not trying to tell you to go download it or to go buy it or whatever, but I think it's really good. But that's my tests. Right. Anyway, back to work. Right. Let's just get rid of this. It is a very good album. Right, okay, so this is now falling over because it should throw argument exception when input not Roman numeral. Assert null, let's have a look. Line 43. So we're not getting an exception. So the way that we do this is if, so remember we're red, green, refactor, right? We want to write just enough code to make this work. So we can go if input is not equal to I, or input, I wouldn't do it this way anyway, but I'm just showing you this for not equal to v, or yada 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 yada, right? So if it's not equal to either of those two, I'm going to throw the same exception, except we're going to change the message is not a Roman numeral. Now this will, get rid of that, don't need that squiggly bracket there. So again, for non-developers or non-C# developers, this squiggly bracket is different to this squiggly bracket. So Squidge was out of the room when I said it. So Squidge, this double quotes here and this double quotes here means everything inside it is a string. It's a string of characters, right? But these squiggly brackets here mean everything inside of these squiggly brackets is some code to go run that code and put it where you see the squiggly brackets. You can only do this in C# if you have a $sign first. Don't know why they picked the $sign, but there you go. Right, so remember we're doing the least amount of code required to make the test pass. We're passing in Jeff. Jeff is neither a capital I nor a capital V. And again, it's not passed. Should throw argument exception when input not Roman numeral. Assert contains failed. It didn't find the phrase null or empty, but it did find input is not a Roman numeral. The reason it said that is because I've said here, because I just copy and pasted that test. Let's get rid of that actually. Let's check that Roman numeral is in that string, right? And now the test should pass because we're passing in Jeff. All we're checking is whether it's an I or a V, and it passes. Great stuff. Except here's the problem, right? You should always check your assumptions, right? Let's do string in input. Okay, so remember this is now a theory, right? Which means it's going to run this multiple times for every set of inline data. We know that this test passes when we pass the word Jeff in, right? But what happens if we pass in that, right? If you remember, this is going to run it with the word Jeff, then it's going to run it with I. If we have a look at the code, it says if it's a single I or a single V, or rather if it's not a single I or it's not a single V, throw this message. So when we pass I in, it's going to fail. But we know that I is a valid input to the string. Oh, what's this? Ah, yes, right. II is a valid Roman numeral. This is why you run lots and lots and lots and lots of different tests. I'll come back to what I'm about to say in a moment, because Squidge has asked the question. Dude, does programming like this take a lot of PC resource? I imagine it could take more computing and RAM usage than, say, playing a game on Steam. Actually, it kind of doesn't. If I bring up my system monitor, oh, it's all the way over there. It's on the wrong screen. Let me drag it over here, right? And I go processes and search for writer. There it is. You can see it's using 12 kilobytes of RAM. Now you won't get that out of Visual Studio. That's the other type of app that you would use to run .NET things. But if I run that again, it then takes up 18 megabytes. So it takes up almost nothing. If I do .NET, you can see, so we've got 12 kilobytes, 18 megabytes, 400 kilobytes there and another 200 there. It's a thing called Mono. Don't worry about it. It's, oh, I'm looking at the wrong tab here. Mono is related to .NET, but not really. I mean, it is, but it's not. We'll ignore it for now. So we had a couple of kilobytes, a couple of megabytes, and then a couple of like less than 100 there, another 60 there, and then another 200 there. So almost nothing. And if we look at the resources, you'll see some random CPU spikes because I'm actually doing Twitch at the same time. But when I run this again, yes, it's looking at about 30, 40, 20, 30, 40% of the CPU usage, but also it's doing Twitch, right? It is capturing on the graphics card as well, but there's some CPU bound stuff that I'm doing in Twitch. So it doesn't really take a lot to actually run programming stuff. You can actually run this from the command line, all of this that I'm doing here, and it takes almost no processing power at all. But there you go. Right, so let's go back to the point that I was making, right? There's two things wrong with my test suite now. Firstly, that's valid Roman numerals, and you can actually see a bunch of these tests are failed, right? So this is failing because we're passing in, which one did it fall over on? When we passed in a single capital I, we get input is not a Roman numeral. Well, why is that happening? That's a broken code. We're passing 3 I's. It's not a Roman numeral. An I and a V, not a Roman numeral. It's broken all of our earlier tests. This is what we call regression, right? I've got to make a change to this code here. So if you remember, when we come into parse, we call this, which is doing this, whoops, which is doing all of this. One more, there we go, which is doing all of this. Because in this test, we're passing in IV, it doesn't match that, because it's only checking for 2 input types, right? It's only checking for I or V. If it's not an I and it's not a V, it doesn't count as a valid Roman numeral. So then all of these other tests are failing. We've also got a test that is failing here, right? Because I, our hard-coded 3 in Roman numerals, is now throwing an exception because I is not in that list. What are we to do, old friends? And we also know that this test, where are we? This one here, shouldn't be passing, but it is. This should fail. So what we know is we need to now go back to this and make it a little bit more complex. Red, green, refactor. We've added some code. It's caused some regressions. It's caused some other code that was previously running to now fail. This is related to your question earlier on, Squidge, up there, about what do you do about writing some code that causes some other thing to fall over, or can you recreate a bug? Absolutely, this is exactly what we've done. So what we need to do is we need to do something a little bit more complex. Whoops, just make sure I've got the right window open so I'm looking at Twitch on this screen and code on this screen so I can catch up with you all. So what we're going to do, we're going to do something really complex. It's going to look complex as I write it, but then we'll come back to it later on and we'll actually make it a little bit easier to understand. So what we're going to do is we're going to create a private static list. private static read-only list of strings, and we're going to call it numerals. We're going to say is a new list of string. Right, so we've got some red lines here, and we've got lots of keywords all followed by each other. For those who don't know, in this window at this time, as you're looking at these, all of these orange words are keywords. These are protected words that are specific to C#. You can't use these words to mean anything else. There's a really complex description of what static means. But what I will tell you is what my programming lecturer, my C# lecturer from college and university said to me. Static does not mean it can't be changed. And if you think it does, then that's wrong. Static means that it always exists in memory. You don't have to say, can you see here that we're saying, create me this, ignore all of this, right? In fact, let's go to the other one, right? Can you see this? It says, create me a, var means a bucket of memory. Give me a bucket of memory, give it the label parser, and set it to a new instance of this thing called parser. What I'm saying here is, go and create a new thing. That's literally what new means. Go create a new thing. And this is the thing that you want to new up, to create a new one of, and store it in here. Var means a bucket. You could quite easily say parser, but then it gets complex. That works, but doesn't matter, right? Create a bucket, that's what var means. Put the label parser on it. Go create a new thing called parser and put it in this bucket. And then when I say the word parser, I actually mean the contents of this bucket. With static things, you don't have to do this new stuff. There's pros and cons to using new and using static, but we're not going to go into that. We can go into that another time if we need to, but we don't have to. So we're saying create me something that is private, means it only exists within here, and that only the things within here can see it, right? And I'll prove that to you. What that means is that I can't go, where are we? We are in that Roman numeral God down here, right? I can't access this outside of, of this area, right? That's all you need to think about. List is a type. We've talked about string, we've talked about int. List is a type. List is a memory thing. It says I want a bucket that is a type of list. I want to call it numerals and go create me a new thing for it. The angle brackets here is called generics. That means list of type string. Now, C# is what's called a type-safe language, which means that if I try to, so I can literally do anything with numerals here. I could say numerals.add Jeff, right? That means take this list and add a thing called that is the string Jeff. But what I can't do is that. So I can't do that because it is locked to the type string. 3 by itself is not a string. And you can actually see that there. Argument type int is not assignable to parameter type string. That means the .add method is expecting a string to be passed in and you giving it an int. You can get around that by doing this, but I've literally only added those 2 lines to explain what that list of string is, right? So we've got this list of strings, right? And what we're going to do, really complex stuff here, is we're going to say squiggly brackets. Now, before, when I said squiggly brackets, that meant go run this code. In this instance, it means create me a list of strings and put these values in there. I, V, X, L, C, D, and M. So this now means that numerals contains those values. Anytime we ask for numerals, if we say numerals, let's say numerals dot, now this is going to get complex, but I'll dial it back. Select numeral, numeral. Again, it goes, I tell you what, why don't we just do, we don't have to do any of that. You just have to trust me. Numerals now contains this list of individual characters, I, V, X, L, C, D, and M, which is pretty cool. So what we need to do now, this is where it gets really complex. So firstly, I would never use the equal sign on strings, right? Because there's a bunch of reasons for this, but let's say that input, let's say if I go input is equal to little I, lowercase I. It won't match on either of those, so it will go in. But yeah, let's pretend that lowercase I is correct Roman numerals. Also, right, lowercase I on this keyboard in this setup is lowercase I. For those of you who don't know, that character there, I don't know whether you can see it very well. Let's just zoom in. That character there, that semicolon, I read it as a semicolon. Some people read it as a question mark because there are different cultures around characters, right? Because different languages use different characters in different ways. So that could, in some language, mean I, right? But it will fail because it's not taking into account that culture. So what I would do here instead of this is I would do if string dot equals, right, input I, and then I would say this says, does this value equal that value if you ignore the casing and you ignore the culture? Are they equal? There's a little bit more heavy lifting goes on behind the scenes for you, but that's how that works. I would always use string.equals rather than the equals sign or the not equal sign. So again, for Screech's benefit, not equals. Right? If you wanted to say is input equal to I, you would do two equals. Because in C# a single equals means take this value and set it to that, or take this bucket and set it to that value. Right? But we don't want either of those, right? So let's just comment all of that out. We don't want any of that. What we want to do, we're going to do something that is really quite complex to read, but I'll take you through it step by step. So if, or rather, it can be complex to read for people who haven't come across this yet. So we're going to go input dot, so input is our string. We're going to call dot all, right? All is a method that is provided to us by a library called link. Link is language integrated query, LINQ, right? This allows us to do loads of things like almost SQL-like operations. So SQL is a database technology, or it allows us to use, do you remember earlier on when we did this kind of thing? We're able to put like an if or an else or do some kind of check using this format. We're not going to put that because that would be silly. But what we're going to do is we're going to say character, whoops, character even. So ch in this instance is a temporary throwaway variable, right? It's a temporary throwaway variable that we're not really bothered about. You can see this tooltip that's come up that's saying like, let's just make sure that you can actually see that. Yeah, you can. Okay, fair enough. Whoops. Oh dear, I've lost my window. There we go. Okay, so this is a temporary throwaway value, and it means that, remember I said earlier on that equals and then the arrow sign? That kind of means goes to or is equal to. Dot all says for every single entry in this list. We've done input. Yep. So it takes input, right? Something to know about C-based languages is a string is called a string because it's a string of characters. So where we've said, let's just take this, right? Is null or empty is a string of the individual characters I, S, space, N, U, L, L, yada, 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 right? So we're saying take input as a string, split it into individual characters, and for every single character, for all the characters in that string, run this code, right? And then for each of the characters in that string, so when we pass in I, it will say for the first I, copy it to a thing called ch, and then do this, whatever this blank space is going to be. Hopefully that makes sense, right? Now we're going to get a little bit more complex. We're going to say numerals, right, dot contains ch. That's really complex because it doesn't like that, right? Because ch in this instance is a character type. So input is a type of string, right? This is going to complain at me. I'm just wanting to show you something. So input is a type of string, where ch is a type of char or character, Remember I said that strings are literally strings of characters thrown together, right? In this sentence here, I is a character, S is a character, space is a character, N is a character. And they are strung together almost as if they are like, if you imagine, I don't even have any sticky notes. This is a real shame. I don't have anything that I can use to show you an example, but imagine you have a couple of pieces of paper, right, and each one has a letter on them, and you run a piece of string between each piece of paper. That's almost how strings work in memory. It's not exactly, but anyway. So this is complaining because ch is a type of character. So we need to do some C# silliness and say, take that ch and convert it to a string. That's what all of these. There's going to be hundreds of these brackets, so I'm going to space them out. Let's space them out just to make it easy to read, right? So for every single character in that input string, run this. Numerals.contains, right? That will return either true or false. That says every single character in this input, does it contain all of the characters in there, or one of the characters in there, right? This is almost like saying, go through, if I had, let's say, if I had input was equal to I, then what this does, input.all, converts it to input.all ch, converts that into I. I feel like I is let's do IV. That's easy to grok, right? So that converts it into I and V. So it's just one character at a time working its way along there, right? Numerals.contains takes this one and reads them one at a time. And ch. That means, right, take ch and compare it to all of the characters in the list, right? And it needs to, numeral.contains needs to return true for one of those, right? It will return true for one of those. Does this list contain that character? Does this list numerals contain I? Then does this list numerals contain the letter V? And then if we said IVX, right? Right? It says, does this list contain I? Does this list contain V? Does this list contain X? And then I could say Jeff, and it would say J, E, F, F. Does this list contain I? Does this list contain V? Does this list contain X? Does this list contain J? Does this list contain E? Does this list contain F? Does this list contain F? If any of those return false, I'll give you a big clue. That's the first one that will return false. If any of these return false, this will immediately fail, right? Let's just clear up all of these spaces. I only put the spaces in there to make it a little easier to read, right? We're then going to make this a little bit more complex, right? Oh, what am I missing? I was missing a bracket. See? That's way too many brackets. Loads of brackets, right? So we're doing all of this, but remember, this I might look different in some other culture. So we need to say string comparer, right? This really cool window here shows you, this little pop-up here shows you all of the different things you can pass in. Again, we want to do, really we could do either of these two, but I'm going to say current culture, right? We used invariant culture earlier on, I'm going to use current culture now. So that says, get the culture, this gets really complex, but get the culture that this computer is set to. So my computer is set to EN-GB because I speak English and write English and I'm in Great Britain. Yours might be set to EN-US. Yours might be set to DE, I think it would be DE, just DE for Germany. It might be set to JP for Japan. It might be set to some other string of characters. That tells the computer what culture you are communicating with it in, and it alters itself to help you out. So I'm going to say current culture which is ENGP on this machine that I'm using, and I'm going to say ignore the case, right? That means, that's this great thing about this, is I could say that, which will split it out to that. This I will match on that I because it's saying, doesn't matter about the case, doesn't matter if it's uppercase or lowercase, ignore that because this I could still be valid, right? You wouldn't really do this in a proper Roman numeral parser, but this is only pretend code for stream, right? So anyway, we're going to do that. I'm going to leave this in here so that we can understand it a little bit more, right? Then I'm going to go throw those. Wow, throw new argument exception, and we are going to say, we're literally just going to copy this line here. There we go, right? Take these out because we no longer need them. That's another thing to do is tidy up as you go along. There's a principle in programming called the Boy Scout principle, and that is tidy things up or make things a little bit better than they were when you got there, right? So all of these comments here, not needed. That isn't needed. We don't need that anymore. So I'll tidy up, get rid of it. So I'm going to rerun all these tests. I'm still expecting some things to fail because this is complex code, right? Excuse me. But again, what we're saying is when we pass that in, split it up into all of those. All of these have to pass return true for the string to be valid. That's probably not a great explanation of how this works, but it will do for now. So we'll run this test. Sorry, excuse me, run these tests. Now I'm expecting this one to fail. Oh, and it did. All of these failed as well. Right, so this failed. Why did this fail? So we passed in Jeff. Let's have a look at this test. Why did it fail? So we passed in Jeff, and we didn't get a. Oh, interesting. See, this is what's great about this. I'm gonna debug this. I'm gonna step through it one line at a time. I'm gonna put a breakpoint in, and I'm going to right click, and I'm going to debug. That means run it, but allow me to see what's happening every step of the way. So let's see that. Oh, interesting. It didn't actually run it. Try here. Let's try again. Debug this unit test. It's not doing it. Let's rebuild everything. Okay, unit test. I'm not sure why this isn't running, but we'll find out. Huh, okay. Inconclusive because it didn't run the test. Fair enough. Anyway, this one shouldn't pass, right? Should throw argument exception when input not your Roman numeral. Oh, I see why. Right, one big important thing, right? We've said when the input matches, when it is a Roman numeral, throw the exception. But what we want to do is we want to do it when it doesn't match that. So we have to make this really big complex thing, take this big complex thing and make it a little bit more complex by doing that. So this says, the bang or exclamation mark there says, go do this, and then whatever the answer is, if it's true, make it false, and if it's false, make it true. So let's talk through this, right? We've passed in, we are going to pass in II for the first one, right? Which means I'm going to take all of these lines and recreate them here, which means it's going to go I, it's going to split up into two. And then it's going to say, does I exist in numerals? Yes. Then it's going to run it again for that second I. It's going to, does I exist in numerals? Numerals? Yes. So then the response for this bit is yes and yes, yes and yes, which means yes. If we got a no there, it would mean no, because we're saying all, which is and all of these things together. Whoops. And then this bit, this exclamation mark, turns that, so exclamation mark turns yes into no. So because we passed I in, we are never going to get into here because it matches. If we pass Jeff in, whoops, then we get J-E-F-F. Does J exist? Nope. Does E exist? Nope. Oh. Let's copy this line just to make it easier. Does E exist? No. Does F exist? Right? So that's no and whoops. And no and no. Whoops. And no means no. So what we're saying is Jeff doesn't exist in this list. And then because we've got this bang, this exclamation mark, it turns yes into no, also no into yes. So we've got the answer is no. So it turns it into yes. So then we will go into here and raise that exception. Really complex way to read this, but trust me, it works. Hopefully that made sense. If it didn't make sense, we'll go through that explanation again a little bit slower. So we've still got a failing test, right? But the failing test makes sense because we've passed in II, which is a valid Roman numeral. If I type in Jamie is a Wally, for those who don't know, Wally is a UK English term for idiot or silly person, and Jamie is my real name. Now this is, what do we think is going to happen here? Because I is a Roman numeral, and I is a Roman numeral. I'll throw it over to the chat. Let's see what we think is going to happen. What's going to happen? Whoops. Oh dear. Sorry, everyone. What is going to happen with that? Is it going to pass or is it going to fail? Just sort of sit around and wait another. So the reason I'm sort of sitting with this dead air is because I know that my internet connection means there's about 20 seconds between me saying something and it showing up. You're absolutely right there, Squidge. It will indeed fail, or rather, we will get this exception being raised. My question was poorly worded. What's going to happen is Jamie as a Wally is going to go in, so it's going to. I'm not going to run through this whole thing. Jamie is a Wally. Exactly. Yes. Sorry. So you're both right. I worded my question badly, so it's going to split this into Jamie is a Wally. Look at that aesthetic, right? That's going to come out as no, 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 yes, no, yes, no, 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 no. But because we are saying all of them have to be yes or all of them have to be no, if all of them are yes, brilliant. And if all of them are no, also will return no. But if some of them are yes and some of them are no, all says they've all got to be yes or they've all got to be no. Yo bro, making a parser. Indeed. So said who 12, thank you for stopping by. Indeed, I'm making a parser. I'm making a Roman numeral parser. Let me just show you. So I'm writing some code which will turn these into these. Right? You're reading a book on compilers. Oh my goodness. Is it the dragon book? That's what I have to ask. Is it? Sorry, I keep looking over here because this screen over here is where the chat is. And over here is where you all are. So, said who 12, are you reading the dragon book? Is it the book with a knight and a dragon on the front? If so, awesome. I'm not doing it as a compiler, but just as a parser. But yeah, brilliant. I have the PDF. I wish I could buy the physical version. I know you mean it's an expensive book. So, all says every single character here has to match. Otherwise, it's no, right? So Jamie as a Wally comes out no, 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 yes, no, yes, no, 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 parking on the lawn. That's a little British humour. Mic's a bit low. Oh, I do apologise about that. It's because the mic's a little bit farther away from me than I'd like because I have a clacky keyboard. Let me mute. Bring the mic a little bit closer into shot and it should be a little bit louder. So this, because it's all, it has to say all of them has to be true. But because we've got some true and some false, it says, nope, you've said all, so it comes out as negative. And then because it's negative, not all of them are in there. And then we negate it, it gets all confusing. Let's just undo that, so we get this back to where we were. So because Jamie is a Wally is not a Roman numeral character. Yeah, you know about context-free... Oh my goodness. Yes, context-free... Oh, the grammars. Oh, I didn't take a compiler course, but I did read that book, the Red Dragon book. Just so that everyone knows what that means. Compiler book. Dragon. There we go. The book that we're talking about is this book here, Compilers, Principles, Techniques and Tools, which is called the Dragon Book because there's a dragon on the front cover. And it has a long title. And, you know, us developer types are kind of lazy. This is like the accepted book for learning how to write compilers, which is something that takes code like what I'm writing and turning it into some kind of executable or binary, right? So that's pretty cool. Yeah, so that's... Yeah, Roman numerals do get a bit weird. I'm only covering these cases, I, V, X, L, D, C, and M. I know that Roman numerals kind of have support for decimals. We're not doing that. So because we're passing in Jamie is a Wally, that is not all a Roman numeral. So when I run this, right, it will throw the exception because it doesn't... This bit does... Oh, bother. Because this bit doesn't come back as true for every character. That is a really good point, said Who12. I did not know that the ancient Egyptians used binary. Look at this, all my tests are passing. Excellent. So this is a little complex. I'm gonna have to lean because camera's right in front of this button I want to push. Okay, so what I'm going to do is just do a little bit of cleanup. Remember the Boy Scout rule of leave it a little bit tidier than when you started. Move that out to its own file. 1, 2, 3. Just to make that a little bit bigger. And then this parser, I'm going to go like this, move it to its own file, 1, 2, 3, just because I like to have separate files for things, right? So in the parser, we pass in, must be a Roman numeral. If it's not a Roman numeral, we raise that exception. If it is a Roman numeral, we continue on with this, right? So now we are protecting ourselves against it not being a Roman numeral. I'm going to leave this big comment in because what I'm going to do is I'm going to commit this source code into GitHub at the end of this video, probably off stream, and then link to it later on. We've got our tests here. Excellent. So we no longer need that. No longer need that. We now need to go and fix this parser because we've said that if we give it I, we want it to return 1. If we give it IV, return 4. Otherwise, return 3, right? Because if I say, let's create a really complex Roman numeral, right? 1986, right? Let's do that. You can look online. They used a form of binary and they used it for doing square roots and multiplication. Oh my goodness, that is awesome. I did not know that. In the square bracket there. What I'm going to do is I'm going to cheat a little bit and we're actually going to do this on the web, right? Let me just set it up first. 1986 in Roman numerals. Right. So we're cheating a little bit. We're getting our test data from Google, right? So what I'm going to say is, so 1986 MCML XXX VI, right? It is cheating, but it's not, right? The reason it's cheating is because I haven't calculated it myself, and it's not cheating because if we're writing unit tests for code that we are writing, we would have a number of test cases that would either be provided by the client or the customer or the person who wants that code to exist, or it could be created by a test expert who said, I think we should test against this, this, and this, right? So I'm going to pass in 1986. This is going to be my positive test to make sure that this code actually works. We're going to iterate towards this because we're actually in a position where this doesn't work, right? So I'm just going to close that. So the code is going to fail at this point, right? Because we don't have anything that produces 1986 when we pass in MCML XXXVI, right? So let's run that. We're going to get a failure in here now, in this one. There we go. One test failed because we passed in MCML XXXVI, expected 1986 and got 3 back, right? So that means we need to change this. Okay, So we could, again, we could totally go case, whatever that string was, mcml xxx VII, return 1986, semicolon. Problem is, this isn't actually parsing it. This is like hard coding those rules. So I'm going to take that. So I'm going to take that out, leave it in this broken state, because what we actually need to do is actually parse the Roman numerals. What's going on here? Actually, writing in code is much easier. It is, yeah. Writing it directly in the code is a lot easier. But if we did that and we wrote out every single one of these cases, it would take us till the end of the world, presumably, to write every single possible combination and figure out all the answers and send them back. Why not have the computer work it out for us, right? Because that's what computers are for, right? Okay. Excuse me. Oh, that's a really good point. Yeah, said who 12 says that Roman numerals you kind of have to read right to left. And let's just test that out. We kind of do. So we're saying I, 1, 5. So 1 and 5 is 6. 1, 2, 3, 36 maybe? Nope. L. So L is 50. L plus XXX. So L plus 3. 50 plus 30. 56. M, 1000. Or C, century. So we're saying M minus C, because that's how it works. C from M. So C is 100. M is 1000. 19 or 1900. Oh, sorry, 900. And then 900 plus 1000, right? It totally makes sense to read from right to left. Absolutely. But what we're going to do is we're going to take this one step further from here. We're going to get rid of this switch statement and all of our tests are going to fail. We're not going to, it's great, yeah, we could do it as a state machine. We're not going to. So a finite state machine is do this step and then go over here or go over there. We don't need to do that. What we're going to do is we're going to go list of values equals new list of int. This isn't the greatest way to do it, but it's a way to do it. Again, we need to include something here. So as this code stands, it doesn't know what list means. So in C#, you say, I know what list means. I know that list means a thing from system collections generic. But to tell the code, or rather to tell writer, this is what I mean, I have to include system collections generic. This is like saying, go get all of the code that exists in this place called system collections generic and bring it in so that we can use this thing called list. Then what we're going to do is, this is the slow way to do it. We're going to go for each. So that's literally in words, for each, right? For str, I'll explain what this does in a minute. For str, oops, in input.to array, to character array. There we go. Right, so this says, take the input, turn it into an array of characters. The input is a string, right? Strings and character arrays are subtly different, but don't worry about it too much. Right, so this takes, input dot to char array means, let's say input is what did we say? It was mcml xx, oh, that's v, xxx vi, right? That means produce a character array that looks like this: m c m l x x x v I, right? And then take each one of these and put it into this variable, right? So remember, a var means get me a bucket, give it this label, and put something in it, right? So we're saying get a variable called var. So create this bucket called, that is a var. Give it the name str, which is, we'll call it ch actually. Get this bucket, call it ch, take this thing, which gives me that, and then work your way through this list one thing at a time. First time around, set ch to capital M. Second time around, set it to C. Third time around, set it to M. Next, set it to L. then set it to X, then set it to X, then set it to X, then set it to V, then set it to I. So we'll go through it one character at a time, right? And then what we can do, this is the long form of this, right? Then we say switch, we do that switch statement again, right? But this time it's a lot easier. CH, it's a lot simpler. Case I, we're just going to do break for now. Break means stop here and go back to where you were, right? Case V break. Is it break? Yeah, break's what I want. Yep. And then we go case X break. Now this is saying for each character in this possible list, go do something, right? So we've got a list of values, add 1. What is it? Oh yeah, because it's double quotes. There we go. I, V. Again, this isn't the best way to do it, but it's a way to do it, right? We'll get to a slightly better way to do it in a moment, but the better way to do this is really, 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 really complex code compared to what we're looking at here. I'm just going to catch up with the chat. Am I American? I'm not. I'm from the UK. I do speak with a very strange accent for people from the UK. I have in my past picked up bits of people's accents from all over the place. Ooh. I've had people ask me, where in America you're from, where in South Africa you're from, where are you from in Australia, just because there's lilts in my voice that come out from everywhere. It sounds British. Oh, said who 12 you're Canadian. Excellent. And yeah, you're right, I did need to use single quotes. Again, we're going to add list of values dot add V is worth 5 and X list of values dot add X is worth 10. We may as well just finish this off. IVX, which were the values that we said that we needed? We wrote them down somewhere. Where were they? Let's just get rid of this. Don't need that. Didn't we write them down somewhere? Oh, we wrote them in program, that's why. Nope. Oh well, we wrote them down somewhere, but we got rid of them. IVX. Do we write them in here? Nope. Okay, we'll have to go back to Wikipedia, I'm afraid. So let's have IVXLCDM. Right. IVXL break. Whoops. Break. I'll explain what break means for non .NET or any developers. So that's 50. So what this means is break. This means go through these and then depending on the what CH means. If CH is an I, do this and then stop and go back around to here and do this for each the next time round again. Oh, thanks, W. Gaffey. You're absolutely right. I did add them and then remove them. And then if you see a V, add 5. If you see an X, add 10. If you see an L, add 50. L, and then it's case C, and that's list of values to add 100. Is that right? I think that's right. Let's check with Wikipedia. This is my documentation, right? C is 100, D is 500. That one's one I hardly ever see, but there you go. Case D, list of values dot add 500, and then break. If you don't, so I'll explain what happens if you don't add the break in a moment. M, I always remember this as millennium. That's probably where it comes from. I'm not sure. I'm not great with Latin. Okay, so the break means once you've done this, then stop. Don't fall through to any of these others. Go back up to here and go back around again. If I didn't add the break here, then what would happen is, right, it's going to complain at me. The first character, if it's an I, it would add 1, then it would drop through and then add a 5, and then it would stop. So we'll add that break, right? Then what we do with this code, I did, but I removed them. Indeed I did. Okay. And then what we do, oh my goodness, this is where it gets really confusing. So we would then need to add all of them together, but then remove a whole bunch of stuff. And it would get really confusing, right? But for now, we would just, then what we would do is we would, so we add all those together. And then, so we've got that in a list of, we've now gone from this to a list of values. Now reads, what is it, 1000 100, 1000, 50, 10, 10, 5, 1. 10, 10, another 10, 5, 1, right? I guess we're just not used to Roman numerals. Exactly, right? I don't know about over in the States or Canada, but there are a lot of clocks over here in the UK that have 1 to 12 in Roman numerals around their faces. And we also have, at the end of TV shows, programs, and movies, the copyright is usually done as a, it's usually listed. Let's say you're watching an episode of Doctor Who, right? It will say copyright, and then C, BBC, and then it'll say MMXX. And that literally means copyright BBC 2020, right? So, you know, it's not required, but for some reason, probably because the BBC started in like the 40s and 50s, that's how they put the year that it was copyrighted, but I don't know. Okay, so that's what it now reads as. So this is where we get really complex and really complicated, because now we have to take this list of numbers and because it's like a mix of base 10 and base 5. Indeed, you're absolutely right, said Who12. So then we'd have to take this. So we're not going to do this, right? This whole setup is really confusing, because then we have this list of numbers and we have to figure out a way of adding them together and subtracting them. Maybe we could start from the right hand side, and as we said before, this plus this, and add these together till we get to one that's the next size up. It gets really complex, right? But what we're going to do, and we're going to take this and do it ever so slightly differently. So I'm going to get rid of that. You can see this is a huge amount of code, right? But what we're going to do is we're actually going to create something that looks a little bit different. So inside this class, we're going to create a public enum, right? We could probably use this everywhere else. Numeral, there we go. So an enum, for people who don't know, if you're not from a C# background or a C background, enum is an enumerated value. It means that this thing, I'm going to create a bunch of named values and they mean something, right? So I'm going to say I equals 1, right? So that means I can go numeral.I for value, right? And value is actually, it's now it's a numeral, but if I did value as int value, or rather, this is really complex, but int value, whoops, that's super complex, that's not what I wanted, right? It's coming up in grey because it's never used, but this actually means take the numeral.I and get the integer value for it, and that's this. It's kind of complex how you have to do it, but that means that I can then get a 1 instead of having to type 1, which is kind of complex, but let's not worry about it. So what we're going to do here is we're going to quickly add I, b equals 5, c, x first, x equals 10, c equals 100, d equals 500, m equals 1000, and we're actually going to add a default here, which is kind of like it's also known as a sentinel value. Default equals 0. I'm going to put a little comment here. Can't parse this numeral. Okay. Sentinel value. Okay. I've misspelt the word sentinel, so let's have Ryder fix that for me. Sentinel. Okay. Yeah, if you want to look those up, sentinel values is kind of like just catching up with the chat. So said Who12 says, can they even do decimals? They can. It's in the Wikipedia entry for Roman numerals. It's way too complex for me to understand. I can't quite grok it. They don't have a 0, so the Romans didn't actually have a concept of 0. 0 wasn't a thing. You could have nothing of something, but nothing and 0 to them were two different ideas. 0 is one of the biggest innovations that the Arabic number set, which is what we use right these days. 100 is Arabic numerals, 500 is Arabic numerals. Any number that you could type on your number pad is an Arabic number. 0 was one of the biggest innovations that the Arabic number system brought to us. Okay, so you can think of this as kind of a lookup. Anytime I want to, anytime that I want to get a C, I can say that it means 100, right? So what I'm going to do is I'm actually going to take all of this code. Actually, I'll comment it out, right? There we go. Right, put a little comment here. Old code, don't use. In real life, you wouldn't comment code out, but I'm keeping it there because I'm going to commit this to source control, and you can see like how it has grown. Okay. So what I'm going to do, I hardly ever do this, but I'm going to write out the algorithm we're going to use, the steps we're going to use. So we need to read each character, read the current character, there we go. Then read the next one, right? Once we have this character and the one after it, we then know whether we need to add or subtract, or whether we need to skip over. Yeah, WGAF, you're absolutely right. You could do fractions with Roman numerals, and it's interesting, but really quite confusing. If the next one is the next value, which is a bad way of putting it, next value up, then we need to subtract. Whoops. Its value from the next. So subtract the current character's value from the next one, and whoops, move along. Move on, oops, to the one, oops, after that. Ooh. So this is the kind of the steps I'm going for, right? Take this current value, look at the next one, do we need to add or subtract, and then move on and add or subtract, move on, add or subtract. So my example is going to be if input is equal to XLV, then what we want to do, we're going to read X. I understand it as I have read a bit about the Dewey Decimal System. Yeah, base 12. My goodness. Read L. We subtract X from L. And then store, whoops. And we want to store 40, which is X minus L. Or rather, L minus X. L minus X. And then, whoops, we're going to read V and loop background. Read V, and that would be, because there's no value after it, store 5. Does that make sense? Hopefully that makes sense. So the code that I'm going to write is going to be really complex, but I'll talk you through it as I'm doing it. Hopefully it'll make sense. So we want to do, so we did a for each last time. This time we're going to do a for. For is simpler than a for each, I think, but it depends on how versed you are in C# and C-based languages. So I'm going to say for. I hit tab because Rider is cool like this. It can auto do things for me. I'm going to say int I equals 0, input length. Yeah, length. Okay. So it's grayed out because I'm not actually doing anything. I'm also going to change this to var just because it's easier to read. So nope, it's going to stay grey for the next couple of minutes, just while I explain what this means. So this is create a loop that is a type of for loop. This says create a bucket, a var, a bucket, call it I, and initially set it to 0. Then add 1 to it. You kind of have to jump left and right here. Add 1 to it, and if I is less than the length of the input string, in this instance, if we're saying MCM LXXVII, VI, we need another X, right? Length equals, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9 is 9. So then what we do is we say if this value is less than 9, go and do this stuff in the middle. Then when we're done, add 1 to it, check whether it's less than the length, do this again if it is, add 1 to it, do it again until I is either equal to or is equal to or greater than the length of this string. So when it is 9, we drop out. Okay, hopefully that makes sense. Do this until for every character. This is like for every character in the input string, do this. But because we're going to get in this first instance, we're going to get the character at 0 and then the character at 1. We need to do it as a 4. We could do it as a 4 each, but it gets really complex. So, also in C#, so input.length, remember a string is like an array of those, or a list of those characters. In C#, lists and arrays start at position 0. In other programming languages, they start at position 1. So that means that the position is 0, 1, 2, 3, 4, 5, 6, 7, 8. Oh, it's 8. Okay. Yeah, it's 9. Okay. So if we want the 5th character, or the character at position 5, we would say that it is that second X. It's really complex, that. And different languages treat it differently. In, I want to say JavaScript. No, JavaScript's not right. In other languages, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9. But in C#, it's 0, 1, 2, 3. Different languages do it differently, right? Okay. So we're going to look through every single character. So what we want to do is we're going to get the ith character. That's a really complex way to say it. Get the character at position I. Okay, so for our current equals input I. Okay, that gets me the character. Remember, a string in C# is similar to, but not the same as, a character array. So this says, go get me the string input, and then find me the thing. Find me the thing at position I, which is a character, right? So in this instance, the first time around, this is going to be M, right? Then we're going to go file next equals input I plus 1. This is going to be C. Let me just put a tab there so it's a little bit easier to read. Whoops. So that it'll line up. Okay. There we go. So the first time around, current is going to be M, next is going to be C. Okay? But those as characters are kind of useless. We're going to do something now where we take that value and convert it into this enum, right? In C# you have to jump through a bunch of hoops to turn a character into the value based on its label. Remember, these are kind of like labels. Is it this one? Nope, that's the wrong button. This one? Wonder if it's that. Oh well. Remember, right? These values here, I through to M, are kind of like labels. If I say, get me numeral.I, it's going to give me 1. If it's numeral.M, it's going to give me 100, which should be 1,000. So what we need to do is we need to do some jumping through hoops in C# to get the current version, the current value as an enum. So for current as enum, this is where it gets confusing, right? We're going to do enum, which is a set of things we can do with enums. We're going to go parse. Parse means what we're doing here. Take a thing of one type and convert it into another. So we need to tell it what type we want. So we just say type of numeral. That's the first thing we want to pass in. And then we want to say current. And then we want to say true. Now this is going to complain because current is a character and enum.parse takes, I can't really draw it on the screen, but up on that top line it says method object system.enum.parse. It says type enum type string value. This is what it's complaining about here. It can't convert a type of car into a type of string. This is a char, but it wants a string. So we have to do more C# nonsense. There we go. Right. So then this gives me an object, which is largely useless. It's not useless. We can do a number of things here. There's a technique in C# where you say to the C# compiler, do this thing, but pretend it's something else. It will fall over at runtime. It's called boxing. You box something and unbox something. Remember that the metaphor I've used so far of buckets? Well, what we're going to do is we're going to take this calculation, this line of code here, right? And this comes out as an object type. So this goes into the bucket of an object. Remember, we can have different types of objects, different types of buckets. We can say int some number equals 4, some number equals 4, and we can go string some string equals hello. Oh, I've put minus there, that's why that doesn't work. Try that again. Okay, so in this instance, some number goes into a bucket that is a type of int. Some string goes into a bucket that is a type of string. You can't put strings into ints, and you can't put ints into strings. You can, but it gets complex, right? What we've done with this line is this gives us a thing of a type of object, but we want to put it into a bucket that is a type of a numeral, this numeral enum, right? And the way that we do that is we say to C#, I know what I'm doing, just shove it in this other bucket. That's what boxing is, right? Which is what that is. That's really complex, right? That says take this thing, pretend it's something else, and put it in there. So if we hover over this now, we can see that it is a numeral. And then we do the same thing again. We rename this next as numeral. We call it next. This is really, hopefully this code isn't too complex. So we've got the current character, which in the first time around is M. The next time around is C. So then what we do, we don't actually do that. That's a bad way to do it. What we want to do, there's two ways we can do this. We can either do a ternary or an if, right? So what we do is var next as enum. This is going to complain in a moment. Equals numeral.default. There we go. Right. And then we say if next if I is I plus 1 is less than input dot length. So what we're saying here is if our character I, so if we get to the end of the string, right? Let's say we're at the end of the string, right? That I character at the end. We're at, so let's rename this so it's a lot less index. There we go. So if position index, let's say that index is equal to, so 0 base, so it's 8. Then input, got lost on my keyboard there. Input index will be I, right? So what does that mean? We can't go past the end of the string, right? Because in C# that is, it would be an illegal operation. In C and C++ and JavaScript, you would likely get an undefined. So imagine you have a list of buckets and you get to the last one and you say, give me the value of the next one. There is no next bucket. So in C# that will say, hey, you can't do that. In C-based languages, that will be whatever is in memory at that point, right? So we're going to get a question mark there. So to protect against that, to protect against that, what we want to do is, whoops, let's do this. Only if the next thing is available, if we're in this position where it's I, we're going to leave next as enum as default, because then we know that default is our sort of stopping position. It's used as a, hey, we can't parse this character because this character doesn't exist, right? However, If there is a next one, then we'll grab the next one. If there isn't a next one, like when we're on that last character there, that I, then we'll leave it as default and move on. Okay? So, that's got now our values. Now we need to do some maths. Okay, if next as enum is greater than current as enum, so if we have m and c, so let's just get rid of this, go back a second. If m and c, so if next c is greater than m, if we scroll back up to the top, c is not greater than m. So we'll come back to that in a moment. Whoops. Else list of values.add, and then we do some more boxing. Current as enum. Okay, so this is more boxing, right? We know if I scroll up, sorry about the scrolling, folks, is these values here, because they don't have a decimal point. If I did that, it would have a decimal point. But because they don't have a decimal point, we can presume that they are integers, which is whole numbers. So I'm saying get that value of this type numeral and pretend that it's an integer, i.e. get its value, right? Scroll back down here. So we're saying just add it to that, right? This is where it gets a little bit more complex. So what we do is we say list of, oops, got lost on the keyboard there, add next as enum minus current as enum. So because we use the minus there, it automatically converts it to an integer for us. What happens is this calculation happens, it goes and gets those values. I'll just scroll up. So let's say we've moved on to the next position, so that's C and that's M, right? M, because C is next is M, yeah, because M is greater than C, it goes and gets M and C. So I'll scroll up again. So it goes and gets the value of M, which is 1000, and the value of C, which is 100, subtracts them, and because it's a subtract operation, it automatically converts it to an integer, so we don't need to box anything, right? So it does 1000 minus 100, store it in this value, right? And we also need to go index plus plus. It's the only time when we need to plus the index twice if the next one is greater than the current one, because we've already dealt with C and M. We want to skip over those to the next one, right? So let's say we're doing C and M, we get C, M there, C there, we get 1000 minus 100, right? So we get 900, we add that into there. If we just went index plus plus, we'd get M and L. We don't want to deal with those because we've already dealt with M. So we do index plus plus, so index plus 1, then that becomes L, and that becomes X. And we iterate through the loop again. Really complex, but I hope that explanation made sense. Then all we need to do, once we've done that, just check on here. Okay, then all we need to do is we need to use link again. We say a list of values dot sum. This is a really cool shorthand, right? I'm going to return that value. This is a really cool shorthand because we have a list of numbers. In this instance, we'll have, where are we? We'll have 1000. So we'll have, let me just put this here. We'll have 1000, 900, 50, 30, or rather 10, 10, 10. And then we'll have 6 because the V and the I get added together and the C and the M get subtracted from each other. So at this point, before we run sum, list of values will be equal to 1000, 900, 50, 10, 10, 10, and 6. Whoops. Let's just do that. There we go. So we could totally go through that loop ourselves, iterate through that loop ourselves, and add them all together. And to do that, we would go for each variable in collections. That would be list of values var val, right? And then we'd add them all together, and that would be difficult because we then have to do var total equals default int. Whoops, except spelled correctly. What doesn't it like about that? Okay, fair enough. Int. There we go. Equals default. That's because it's implicitly typed. And then we'd go total plus equals value. Whoops. Value. That's the long form version. That's a short form version of total equals total plus value, which says get that one, add it to that one, and store it in there. Right? I think, hopefully, you'll agree that this is a lot more code than that, and that is much easier to read. It might not be much easier to read in American English, because I'm not sure whether American English talks about summing some values together. British English doesn't that much these days, but that's what that means, right? It's a really complex listing for the code. So I'm going to collapse this, right? So what we do is we come in and we say it must be a Roman numeral. If not, raise an exception. Then create a bucket to store all the list of values in. Then go through every single character and add them all together, or rather go through each character, figure out whether we need to subtract anything or add anything to it, store it in a list of values, and then sum them together. So this time, whoops, when I run my unit tests, all of them should pass. They may not. Let's find out. I may have broken something. And that's totally valid. If I've broken something, then I've broken something. Excellent. I've broken loads of code. 1986 doesn't work. Requested value L wasn't found. Interesting. Scroll, scroll, scroll. L wasn't found. Interesting. Out of range. Okay, so I've broken my indexing. So let's find this first. Requested value L wasn't found. Did I not add L? Oh, I didn't. What was L? L was 50. L equals 50. There we go. Run it again. This test will pass, but those two will still fail, and that one will still fail. Okay. Let's run this. See, this is why we do test-driven development. I've made a bunch of changes, and we want to make sure that all those things pass. Right. This one passed. This one, index was outside of the bounds of the array. So what have I done wrong? Let's go with that one. Index outside of the bounds of the array. Okay, so we're passing in I. So input equals I. Input length equals 1. Input I equals I. So, oh, that's where it fell over. Okay. So, what we want to do is take this. So the reason this fell over, right? Let's talk this through, right? So input is just a string with the letter I in it, right? Which means its length is 1. Input I, let me index. There we go. Input of index plus 1 equals question mark, right? That's where it falls over, because we're saying get the index, which in this case is 0, which points us at the letter I, add 1 to it, which falls off the end of the array, and then it falls over. So let's do, that's going to complain. There we go. Okay. It makes this a little more difficult to read through, but so because index, which is 0, plus 1 gives us 1, is less than the length. I think that's going to break. Input.length is 1. Index, which is 0, plus 1 is 1. 1 is not less than 1. This is really complex, right? Index equals 0. Index plus 1 equals 1. Input.length is equal to 1. Is 1 less than, or is index plus 1 less than, whoops, input.length. No. Okay, so when index is 0, index plus 1 equals 1. If input.length is 1, is index plus 1, which is 1, less than input.length, which is 1. No, it's not. So we don't do that bit. We don't try to fall off the end of the array. We set this to default, which is 0. Is the next one, 0, greater than the current one, which is 1 in this instance? Nope. Okay, so we just add it. Really complex. Roman numerals are not easy to grok. Grok is a term that's sometimes used in programming or engineering to mean understand. So this should mean all of the tests now pass. Excellent. But just because the tests pass does not mean that the code is correct. The easiest way to do this is to start adding lots and lots more inline data. And the more varied the inline data, MMXX, we said that earlier on was 2020. Let's add that. Inline data, let's see, what value should we do? 1460, oh, 1600. That seems good. So that would be 1000. And then, 50 and 10 taken away from, so 50 and 10 is, oh, no, 1000. 10 minus 50 minus 1000. Is that right? Let's check that before let's check ourselves before we wreck ourselves. 1600 in Roman numerals. I shall show you the screen in a moment. Oh, my calculation was completely wrong. MDC. Okay. DC. I'm glad that I checked that. See, this is it. You've always got to go back and compare it with, sorry about that click there. So you always got to go back and compare it with actual live data. So let's go back to the IDE. We're going to say, whoops, we're going to say 2020 is 2020. We say MDC is 1600. Why is that? A decade taken away from a century. That's really, really cool. Okay, so let's run those tests. So we've got to pending and we've got to success. Excellent. So that's brilliant, right? So what we've proved is that for our limited set of cases, this is the great thing about unit tests. For these cases, we could prove that the code does what it should do, right? Squidge in the chat, I'm not sure whether he's still there. He was under the name Waffling Tailors. He asked earlier on, would you write a test that confirms some kind of bug, right? If I knew that there was a bug in the code that said when I passed in XXLDC, it should have, I don't know what, 10, let's work this out. Right, 10, except L is less than that, so that's 50 minus 10 is 40, 40 minus, whatever, right? Let's say that if the user provides Jeff, it should come out with a million, right? This is a cool thing that C# can do. No, it can't. Okay, right. Let's say that there was a bug in the system that when you typed in Jeff, it gave you a million. You could add that test, right? And then whilst you are working on how you're going to fix it, you might be stabbing in the dark how to fix it. Keep running this test until you've changed the code enough that that test there, Jeff gives you a million, doesn't pass anymore. When it doesn't pass, you can then go, right, that's fixed my test. So totally, there was a question that Squidge thought was a daft or silly question. Would you write a test for a failing condition for a bug? Absolutely, because it helps you to get to the point where you can recreate that test in a very fast way. Remember, this test suite, whilst not complex, takes 8 milliseconds to run, right? That's hardly anything, isn't it, right? In the grand old scheme of things, 8 milliseconds is hardly anything at all. So there you go. And you know, in 14 tests, which take 8 milliseconds, yeah, all right, it's taken us almost 2.5 hours to write, but in 14 tests that take 8 milliseconds to run, we've proven that our Roman numeral parser does what it's supposed to do. Now what we haven't actually done, now I created this as a console app, right? What I want to be able to do, bonus, this is the British people get this Brucey bonus round, right? For input equals that, and then for output equals default int. Can we do that still? Yep. And then we're going to go ooh, yeah, okay. So we're going to var parser equals new parser. Excellent. Then we're going to do output equals parser.parse input, like this. And then we're going to go console.writeLine. There's a whole bunch of stuff going on here. I'll talk you through it in a moment. We're going to go string input is output. Whoops, output, which is a really silly sentence to write, right? This is going to fail because we're passing in a blank string. What I'm going to do is I'm going to ask chat to provide me with a bunch of numbers that we can then convert into Roman numerals and check whether they work, right? I'm also, if I get the chance, I'm also going to make a string extension so that we can do input.as Roman numerals, which will be really cool. So whilst you're all thinking about it, I'm actually going to make a string extension method that allows me to go input.as Roman numeral or something similar, right? We'll come back to that in a moment. So Squidge over in the Waffly Tailors has come up with a number. Right, hopefully I can get this number right. Let's see. Right. 22369 9751 in Roman numerals. Okay, so Squidge has come up with a number. Oh, it's not going to let me choose the actual number. Oh, that's a shame. 223615671. I thought there would be like a calculator. Roman numeral calculator. There we go. Ha! So we'll use this, which we're assuming works. I want to do it the other way. Do a calculation and copy the link. No, that's not what we want. Convert to Roman numerals. Aha! Right, Roman number, a decimal number. Okay, so we're going to go 223699751. Convert that. Why is that number not valid? I don't understand. Maybe this website's broken. 2, 3. Maybe I've broken this person's website. 6, 9. Okay. So this person's website only goes that far. That's a real shame. I tell you what, let's just put that. I need to convert. Just calculate it as a Roman numeral first. Oh my goodness. I wonder whether I can reverse engineer my code, because what I want to do is provide it with the actual. Squidge, can you come up with a number that's 4 digits long so we could try it, and then we'll figure out off stream how to actually do this. Would 2236 be okay? Because I want this to output 2236. Console.writeLine, console.readline. I'm going to do that number for now. Oh, okay. So you're saying 5698? That's not valid either. Oh my goodness. I'm going to go with, what did we say? It was 2236. I'm going to go with this one for now. I'm going to copy that. Then we'll switch back to the IDE. Put that in there, right? So what we're going to do is going to say this input. We're going to pretend that output is set to 0. That's what default int is. Then we're going to go and parse it. Then we're going to write it onto the screen. So hopefully we're expecting this. This should read MMCC50 is 22336. That's what it should say on screen when we run this. Who could say? Oh yeah, first time I'm running this, so it's asking me how I want to run it. It's a console app. So edit my configurations. I want to, yeah, okay, fair enough. Let's just run it. Yeah, okay, run. So it should say here somewhere, yeah, MMCCXXXVI is 2236. So we know the code works. Excellent. Okay, so the next thing we're going to do, Brucey bonus task, see if I can do it in the next 20 minutes, is to, instead of having to do all of this, to just be able to go input.as Roman, input parse Roman numeral? Yeah, we'll call it that. We'll call it that. Yeah, okay. So what we're going to do is we are going to make a new class, public static class, string extensions. Okay, so just to kind of explain what this is doing, this whole bunch of code here. So we set we're talking about buckets, right? Create a bucket called input and put this value into it as a string because it's got those bunny quotes. Then create another bucket called output and put whatever default int means, which in this case, it means 0. So I may as well just do that, right? Okay. Then create a bucket called parser, go create a new parser and put it in. And then go to that output bucket, get the parser bucket, get the method called parse, pass the value of the input bucket, it gets really confusing, get that output, which should be 2236, and this line, super complex, right? Maybe super complex, maybe not. Remember, with those strings, if you put a $sign in front of it, when it sees the squiggly brackets, it means go do some C# code and put the value in here. So it's saying, go get me the value of input, which is this string here, and then get me the value of output, which is this integer here, and then write it out as a string, right? I can write this out, I can make this simpler by going like that, but then when I change this value, I'd have to change that value. Okay, right? That creates a string there and passes it into this method called writeLine. WriteLine is literally that. It writes a line to the console, which in this instance is this window here. And then it sits and waits for a line. That's me trying to get it to actually wait for me to type something in. I could have typed something in then. It wouldn't have done anything with it, but it's a cheap trick to make it sort of sit and wait. So in here, what we're going to do is we can't really test drive the development of this static class. Static classes aren't easy to write test driven code for. So we're just going to abandon that for now, right? We're going to go public static string. Oh no, it's not string, it's an int. We'll parse, we call it parse Roman numeral, this string input, right? This now works. That lights up because it exists. This is complaining because we're not returning anything, right? Next step is to take that input and create the integer. Pretty easy, right? So we know, as the person who's written this method, we know it's going to check for us, so we don't need to check anymore. So we're going to just literally call that. So what we're going to do, we're going to do some C# hackery, right? Yeah, first thing we're actually going to do, so we go to this method. I'm going to make this a little bit more complex. We're going to go iDisposable. Implement the missing members. Okay. How do we want to call the dispose on this? Yeah. Okay. So this makes this a little bit more confusing, right? Don't worry about the code I'm going to write, because this just makes it easier to use this later on. gc.suppress finalize this. Yeah. Yeah. Then we want public virtual void dispose. Oh, we want override as well. Virtual override virtual void. Override virtual. Oh, bother. None of this is important code. This is just disposing. Is that right? Protected. disposing oh dear, this is just boilerplate code. You don't really need to do this. gc.suppress finalize this. Okay, you don't need to ever implement this. This is just me doing something that makes it a little simpler. If we're not disposing, do this, otherwise fall through. Right, so the reason I did this, right, is because it makes what I'm about to do easier to do. So what we can do, just check the chat, is we could do something, instead of going for parser equals new parser return parser dot parse input, right? That's perfectly valid. That's 2 lines, that creates a new thing and returns the value. But we could do it a slightly different way. For parser equals new parser, and then return parser dot parse input. Whoops. Is that how it would work? Yes, we need to get rid of this code. That's why. Okay, so what this is, deep C# memory usage knowledge, right? This using statement here means go create me a thing, and when this context ends, when this closure ends, make sure to delete this from memory because we don't need it anymore, right? But it also means go create this thing and then do this, right? This and this are technically the same. There are subtle differences, but it's like deep C# memory usage knowledge that changes how that works. So if I go for output, whoops, equals that, then this simplifies all of this down to that. So if I run this again, with this value, we should still get 2236. Is it working? Is it working? Yeah, 2236. Our manual test is finished, right? The reason why I said that manual testing is slow is, I mean, you saw how long that took to build. Not very long, but it was a couple of seconds, right? About a second or so. Is there a way to find out? If I got to run, nope. Debug, nope. Build, here we go. So you can see it took 1.266 seconds to build it. Now, even if I'm the fastest typer in the West, right, and change this, rebuild and rerun it, then if output equals 2236 console.writeline, right? Even if I'm the fastest typer in the West, debug 2, 3, 4, it's done, right? Let's get rid of that console.readline just to make it faster. Run 2, 3, 4, boom, pass. Then I go through, change that, run it again, 2, 3, 4, pass, 2, 3, 4, pass, versus boom. Yeah, it took 6 seconds to build everything and get it to the point where it's ready to run. But once it had done that, it then only took a further 8 milliseconds. And that's why I love unit tests. That's one of the reasons why I love doing unit tests. 1, 2, 3, 4. So I saw on Twitter the other day, Paul from codeshare.co.uk, Squidge will get that. Oh, actually, we can make this simpler using new C#. I'll come back to what I was saying in a minute. C# 8, I think, code. Now this, I'm not a big, personal opinion time, I'm not a big fan of this. Only because it is not immediately obvious where that using statement starts and ends to me. That makes sense to me because it says, whilst I am in this block here between these two squiggly brackets, that way around, open, close, yeah, between these two squiggly brackets, the bucket for parser exists, Outside of that, it doesn't. But in that, it's not immediately obvious to me. It should be obvious because Parser, whoops, doesn't exist here. That's where Parser doesn't exist, right? Same thing could be said, whoops, for that code. Then I need to wrap this in brackets. Same thing could be said with that. Parser doesn't exist where that comment is. And the same thing could be said that, but that to me isn't immediately readable. That would be. That's a little bit more readable because because of some old C stuff. But I'm going to leave it like that just because I like that. Anyway, that is 2 hours and 30 odd minutes of me going from no code to a Roman numeral parser with test-driven development. I'm going to go and commit this code up onto GitHub, and I will tweet out the link to it. So if you would like to see the link, just bear with me a second. .NET Core Show. Okay, so if you would like to see the link later on, go and check out the .NET Core Show Twitter account, and I will send that out in a moment as soon as I've got it committed, which should be in the next 10-20 minutes, because I'll need a bio break after we've done this. But as soon as I've got it up and committed, I'll tweet out a link to where you can pull the code down if you want. While you're there, maybe give the show a bit of a look, because if I do this, because the podcast is pretty good. If you're into .NET Core, it might be worth checking out the podcast, which is here, the .NET Core podcast. There's 60 episodes so far. If I go to the press kit over here, what I'm going to do, I'll drag this over here, so then I can see it and you at the same time. So if you look at the press kit, ignore this first line here. There's 60 episodes, around 50 hours of content, loads of stuff to listen to, right? Loads of different episode stuff. Each episode, if I scroll down to, say, here, each episode has a player on the webpage, and it sometimes has some ads, but it also has a full transcription of what was said with, if you'll allow me to jump to the end, loads of links to related things. So it might be worth checking out if you're a .NET person. If you are a podcast person, it might be worth checking out Waffling Tailors. This is something I do with Squidge in the chat, who's there as Waffling Tailors. This is a video game related podcast. You can see over the last 3 weeks we've talked about Final Fantasy VII Remake really, really deeply. And then before that we've had conversations with video game developers. It might be your thing. If not, totally fine. Move straight on. That's not a problem. But anyway, with all of that being said, I'm going to love you all and leave you. Thank you all ever so much for showing up in the chat. I apologise that it's been a bit hit and miss in places, but hopefully you've got something out of it on your wonderful Saturday afternoon or Saturday morning or Saturday evening, whatever time of the day it is. I also want to point out I've got a Space Invader and a Cactuar from Final Fantasy and a couple of books there that are development related. But anyway, I wish you all a wonderful Saturday or a Sunday, because some time zones will be into Sunday now. Whatever it is, have a wonderful whatever time of the day, and hopefully I'll catch you again in another stream soon. See you later, folks. I need to kind of click over here first. I'm talking to myself, but there you go. See you later, folks. Thank you ever so much for watching. I hope it was useful. But anyway, bye-bye.